So let's revisit what the third way of DevSecOps is and how it can apply DevSecOps. So just to recap and review very briefly, the first way is all about flow, frictionless flow without bottlenecks, and in particular with DevSecOps without bottlenecks caused by security. The second way is about injecting feedback along the flow so that you can see what's happening and get details and information to see how flow is going and how you might optimize that. And the third way is, of course, continuous experimentation and learning. And in this context, security is you're looking at security as a learning process, culture, collaboration, experimentation, other strategies like chaos engineering for security, continuous security improvements. We'll look at some other tactics and strategies for improving the third way. One of the core ideas is to build structured experiments to allow for those improvements in learning and find a balance along with everything else that you need to do with DevSecOps. Okay, so finding where to start. The third way emphasizes continuous experimentation and learning, but experiments can sometimes feel overwhelming if you don't know where to begin. The key is to start small, visible, and be safe so that learning compounds without introducing unnecessary risk. The bottom line is the experiments should be limited by visibility. Stick with areas that you can see, or build in observability if you need to do something that you can't currently observe. Basically, if you cannot observe the outcomes, you can't really learn from them. So that's why the first step is to limit experiments to places where results are visible, whether through logs, dashboards, direct user feedback, or other observability, aspects. Work with real users as much as possible. Don't run experiments in isolation. Put them in the hands of real users. And in this case, it may not be end customers, but the DevSecOps pipeline users, for example, to gather authentic, to gather authentic signals and knowledge. Achieve consensus outcomes. You should try to generate results where teams can review them and get agreement as to what worked, what didn't, and what's worth scaling. There's so many possibilities that you really want to be careful as you go and get agreement. Prototype and test. That's about building small prototypes and quick tests. The goal isn't to try to achieve perfection in one go. It's more about progress and validating learning as you go. Organize things as experiments. Walking skeleton is a concept that you may not be aware of. One great starting point is the walking skeleton, which is a minimum end-to-end implementation that touches every stage of the pipeline. It doesn't do that much, but it ensures the skeleton of the system works. So this is not a complete MVP. It's more like quick ideas. Whereas minimum viable product is a safe entry point. Instead of waiting for a perfect release, get a small usable product into the hands of the stakeholders and start learning. And again, when we're talking about product, we're talking about things like DevSecOps solutions and tools and processes, and even people aspects. There are 3 key details for success. Empower teams. So teams must feel safe and empowered, but to try experiments without fear of blame. Leadership needs to set the tone here. Also provide information and context. Make sure teams have visibility into metrics, risks, business context. Without the information, experiments don't really teach you anything. And leave details to workers, meaning leaders shouldn't micromanage experiments. Give the teams the autonomy to decide the how, and that's where creativity and innovations can really thrive. So, closing thought on this slide, the third way with DevSecOps doesn't begin with massive overhauls. It begins with visibility, small, safe experiments, empowered teams. Over time, those steps compound into more transformational changes. Okay, slide. Here we're talking about quantitative and qualitative analysis. Second trouble. having trouble to get slide to cooperate. Yeah, so there's two types of experiments that can mix results from, that can mix results. But most basic experiments depend on these options. So quantitative deals with using numbers, collecting metrics, and assessing results. Qualitative deals with an understanding of the experience and generating context around subjects for better understanding. So as it shows on the slide here, qualitative usually has to do with collecting opinions and words, parsing ideas. It's used to understand concepts. Generally, you're gathering in-depth insights from people. Key terms are things like understanding, context, complexity, subjectivity, or relate to this. There's a lot of subjectivity. It's not, hard numbers. And you can collect qualitative information through interviews, verbal open-ended questions, maybe focus groups, group discussions, ethnography, which is to participate in communities to observe culture. So that could be somebody embedded in the team watching, or literature reviews, surveys, other work. Those are examples of qualitative, and quantitative is more about expressing information in numbers and gathering data to do some analysis. Graphs can help to see trends and so on. We want to test and confirm theories and assumptions against some data, creating generalizable facts about a topic. Key terms here are testing, measurement, objectivity, replicability. Can you repeat something consistently? Here, there's lots of methods. We'll talk about some surveys, experiments, and observations. So surveys may or may not be quantitative. Some of them are kind of qualitative, but they can be quantitative. Okay, so let's go to the next slide. Here we're talking about data analysis. Data analysis is key in doing any experimentation, or at least understanding the results of an experiment. Visible analysis must be structured to solve a problem. Otherwise, you're not really sure what you're analyzing. Experiments with too many variables and lack of clarity can actually cause more issues than it solves. So meaningful data means it relates to actions you can take on a project. If the data is not compared properly, like when you use mean time between recovery matched against lead time to deploy, it can create discrepancies and confusion. Compare apples and apples. Unless the experiment is clear, such as asking if reduced lead times lead to more defects in production with increased MTTR. So, be very clear about what you're trying to analyze. Yeah. Okay, let's move on to the next slide. These are just components of analytics. Data bit virtualization is a type of analytic, of course. You get information from dashboards, tables, interactive elements, graphs, charts. Of course, data governance can also give you information to formulate information against governance rules, watching conducts of the team, looking at builds, enhancements, give you some insights. And optimization, so looking at speed, response, efficiency would be something you're looking for. Data acquisition, so data acquisition is this DAQ, it stands for data acquisition. Maybe you're collecting data from devices, applications, drivers, sensors. Roadmaps can also give you information, to validate whether you're on track. This is whether you're following your strategy. Do you have a roadmap? And are you tracking to the roadmap, going off track? Also, insights and analytics can identify, interpret, and help you find value in whatever you're analyzing. And data security, looking at signals from the data, guard bands, data storage, looking at objects and files and blocks. So these are certainly not even a complete list of where you might get data to analyze, and some of this tactics for analytics.